Hello everyone, this is another Unity tutorial, a UI Unity tutorial. This is going to help you make a pie chart in Unity. I'm going to be making a couple tutorials involving graphs, um, bar chart, and a scatter plot as well. Um, so to start, I just set up a very basic scene with, um, again, with a canvas. That's just what you need for UI objects. I've got this background panel. Um, this, let me actually, okay. This background panel is just going to fill the entire screen. And then I've got my full circle. This is what I'll be using to overlay the pie chart on top of. So this is basically the background of the pie chart. And then I've got this legend. So I'm just going to hit play real quick so you can see what it looks like. So you can see that I have the legend showing, and it's all the same colors as the wedges of the pie. And then these values represent the values for each wedge. And this percentage that this wedge is the total of all these values, or it's the value divided by the total. So in this case, 22.4 divided by all of these added together. And that's what this percentage is of the circle. So just to give some details on how you would go about doing something like this, here you have this full circle. If you add an image component, or it should already have an image component if you're using something like this, don't worry about the Pi Manager script right now. Just create a circle and make sure it has an image component. You can change this image type from simple to filled. It'll start out as simple, change it to filled. And then what this allows you to do, if you have your fill method set to 360, is you can change this fill amount and you'll see that the circle will become a part of whatever that full 360-degree circle is. So I'm basically able to create a portion, a wedge of the full circle. So that's basically what we're going to be doing. We're going to be overlaying objects on this full circle that follow this same filled image type. So they have the same component, and with those overlay wedges, we're going to change the fill amount, and then we're going to make sure we match up the next wedge with the fill amount, or based on the fill amount of the previous wedge. So to give you some idea of how that works, I've created a little slower animation of how it loads the info, so you can kind of see what direction it's moving, how it's loading, stuff like that. So okay, so as you can see, it started here. So even though this is the last in the column, it actually is a backwards for loop. So it starts at the end, then it loops up to the front. So this top, this blue or D wedge, it needs to know where E ends so that it can start there. So it needs to know where this point of the circle is, and you can figure that out based on the fill amount and based on what percentage this is of the total, or this is of the total, or sorry, this one. Because if you know what percentage this is of the total, you know how much is left, and then what you can do is you can make sure you start this at the fill amount of based on what is left. So I'm going to do a little drawing real quick, help give you an idea of how it works. So here's the big circle. Our fill amount is a value between 0 to 1, and 1 is 360, 0 is 0 degrees. So this would be 0 degrees, this would be 90, this would be 180, This would be 270. And then, of course, when you get back to 0, it's 360. So I don't need to put that. So we need to figure out what this is in terms of between 0 to 1. Well, it's split into fourths, basically. So 90 degrees is 0.25. Well, actually, I guess first I should say this is 0. 0.25, 0.5, and 0.75. And so when you think about it like this, you can actually get any angle based on just turning it into a percent. So if it's 25%, it's 90 degrees. So that's kind of what we're doing here. If we take the total of, or if we take one of these and divide it by the total, that gives us a percentage, and we use that percentage as the fill amount. And that fill amount, we don't even need to know the degrees in this case because the fill amount is already in percentages. So that will just get converted for us. So we really just need to know what percentage of the total everything is. And that's how much we're going to use for a fill amount. Something else to note, when I was looping through, let's say, let's actually look at these. Let's start at the bottom. This is 0.24. This is 0.42. When I was looping through, you notice the positive direction is actually to the right. So this is positive degrees. So I guess a better way actually would have been 90 on this side, but that's kind of how it works. It's moving a little differently than you would normally expect. I figured that out through trial and error. I thought that this would be the 90, 0, 90, but it seems to be working the other direction. There's probably a way to change that, but I don't want to make it too complicated, so it wasn't that hard to flip it. Anyways, so let's get into a little more how I did this. So let's go into well, first let me show you the prefab of the wedge, so you know what's on it. It's just an image, and it has a fill amount that you can change. And this prefab is basically what I kept spawning to make each of the wedges. Okay, let's go into the script. So to start off, I have this list of pi wedges. This list is where all of our data is going to be stored in the wedge class, which is a class I created. So here's my wedge class. I only needed these 4 variables to store in each wedge, and that's enough information. If you want to add more, to add some more functionality, this is probably where you do it. So I have the fill value. This is going to be basically the value. It's actually not the percentage, it's the value. The percentage we'll calculate later given the value. We have the name, which in this was A, B, C, D, or E in this case, but it could be any name. The image and the color. And the color the image, we're just going to set the image's color to whatever this color is that's stored. Right now all the colors are random. If you want to set up a way for the user to put in their own colors, you can do that. And then this is just a basic constructor, given all 4 of those. There wasn't really a case I could think of where you wouldn't need to give at least some of this information. I could have a default wedge color, but I didn't really see the point. Okay, so let's move to start. This is, because I'm using randomness, I should do this. You should do this too whenever you're using randomness. Basically what it does is you need some kind of seed, and that seed determines the pseudo-randomness. So if you use the same seed over and over again, you're going to get the same outcome, even though it's technically random, because it's only random based on the seed. So the seed is a way for you to get the same random outcome over and over again. So what we want to do is every time we start, we want to change the seed so we're getting a purely random outcome. The way to do that is this init state. You just call this function unityengine.random.initState, and you give it a number that's very unlikely to be the same for the same person. So it's unlikely that someone is going to play this game at the same millisecond, or play this app, or this pie chart. I guess it's not really a game. Use this pie chart at the same millisecond that they've used it in the past, and because that's very unlikely, the seed is basically random. Okay. So here I just instantiated the PyWedges list, and I call load wedges. So let's look at load wedges. So what I'm using a CSV file. Let me see if I can open that actually. So here's a CSV file. It does not need to be in Excel, actually. Let's just open it with Notepad. There. So this is what a CSV file looks like if you want it to be. You're just using even a text file. You can make it a CSV file. The first column is always the variables. So in this case, it's name and value. And then after that, it's just instances of the object. So that's where all this data is coming from that you saw in the graph. It's a CSV file. So we are taking that CSV file, we're loading it from resources. Unity has a pre-built-in tool to load anything from the resources folder. So if I go to the resources, I created this folder, and you would have to create this folder whenever you want to load from resources. But then I just dropped the CSV file in resources, and then I just call resources.load. If you want to drop it in a folder instead, let's say text files, something like that, then you would just use make a path to the file that you want. Just know that you don't need an absolute path. The relative path is always inside the resources folder. So you don't need an absolute path. Also, make sure to keep off the extension. You don't need .csv. It actually won't work if you say .csv. So make sure to just say data. And then make sure you don't have two file types with the same name but different extensions, so it knows which file to grab. So this text asset class is a class that's already in the Unity engine, and it's basically how you load text files. And this text asset has a member variable called text, and this member variable is the text that we want. The text asset class has some other things, but you don't really need that for this purpose. Just need the actual text inside the file. So I stored that in data. I split it by a new line because if you look at the CSV file, every single instance starts or ends with a new line. Okay. And then this portion right here, we know that this first row is always going to be variables, and we already know what variables we're looking for, so we actually just kind of want to throw them away. We're keeping them in the file because that's how CSV files work, and we want to be able to load any CSV file, but we're actually just going to end up chucking that first line because we know what data we're looking for already. If it's in the right format, it shouldn't matter. You could do a check to make sure the CSV file is in the right format, and then based on that check, you can determine whether you can even load a graph or not. That makes sense too. I'm not going to do that, but anyways. So what I'm doing is I'm copying the whole file except for the first line into a new array, basically. Okay. So now we're going to loop through this array that is missing the first row, which is what we want. and we're going to grab the values. In this case, the values, there's two of them. There's the name, and then there's the value field. So two fields. We're gonna create the wedge prefab that we have, which is it's public, so you just change it in the editor. You drop it from the editor. So we're gonna instantiate one of these wedge prefabs. We're gonna set the parent to whatever object the script is on, which in this case, this full circle has the script. We want to make sure the parent is this circle so that we can position it on the circle accordingly, so it's in local space to the circle. This makes it really easy to position it well. Something else I didn't mention actually that is super important in this case is how am I able to put this partial circle, you know, somewhere else on the circle. So for instance, if I have two of these, you see they overlap, and that's not what we want. Let me change the color, make it a little more obvious. So something I forgot to mention is we're going to use the Z rotation to move it somewhere around the circle. So I did mention we were using degrees. This is how we're using degrees. So as you can see, you know, if we were to perfectly line this up with this red triangle, it's always in bounds of the circle. So that's why we're using rotation. I forgot to mention that. Okay. So let's go back to here. So we've set the parent of the wedge. Now we want to zero it out because it's pretty common when you set an object to the parent, or when you set a UI object, especially to the parent of a UI object, it is never zeroed out, even if it was originally in the prefab set to a vector 3 of zeros. So we just zero it out. And then we deactivate the wedge. We don't want the user to see it. We do this mainly for the slow loading version. Let's see. I think it's already on slow load. Yeah. So this is called slow load. So technically, all the objects, if you look to the left here, all the objects are instantiated immediately, but they're just slowly being turned on. We do this so that you don't see all the objects at once, and we want to wait until they're positioned before we show them. This function is actually used for both the slow load and the fast load, so we do technically deactivate the objects in the fast load as well, but we turn them back on immediately, so it's not even really a noticeable effect. So, okay. So we also need to grab the image component. We know there's an image component because our wedge prefab should have an image component. You could even put a script on the wedge, and the script could require a component image, and then that would be a complete guarantee. You could do that. I didn't do that. But anyways. And then we have, here, let me just show you real quick what I mean by require component. That's what I mean. You put that as a header, and then you would say image. And you would put this, you wouldn't put it here, you'd put it at the top. You know, like, you know, in these fields here. Actually, no, it might even be above the class, I think. I think you put it above the class. But I didn't do that. I didn't think it was that necessary. And then the fill value, remember this is the value from the CSV file. It's not the percentage value. Okay. And then here, I'm doing a check to make sure the value they gave was a floating point value. So this second column, I want to make sure this is a number and it's floating. I mean, it can still be an integer, and that can be a floating point value as well. It can't be letters or something else like that. So that's what this does. It's a try parse. It tries to turn it into a float. If it can't turn it into a float, it just returns false. If it can, it returns true. And at the same time as we're try parsing, so we're checking to see if it's can be a float. We're also storing it in this fill value using out. So out, you just give it a reference, and it'll fill that reference inside the function. So that's what's happening. This function is simultaneously producing a value and also checking to make sure the value is a float. That's what's happening. Okay, and then inside this this bool check, the floating point value check, we're going to generate a random color. Colors are RGB values, and the R, G, and B are all values between 0 and 1, which is why you see this random range between 0 and 1. We're going to grab the name value, which in this case is just the 0 index of the values object that we, from right here, when we split by the comma. So this is value 0, values 1. We create a new wedge because we have all the information we need now, and we set the color of the image object, or the image component, to the color that was made up here. And then we're still adding, we're adding to a total, because at the end we want to know the total, the total of all of these values, right? Because that's how we're going to determine what percentage each of these is of the total. So we use this, we want to add these numbers as we are creating these objects. So that's what we're doing. This total, we're just going to keep adding values. And then finally we can add the new wedge we just created to PyWedges, where it will later be used to position. So none of this was used to position the PyWedges. This was just instantiating them with the data that they should have, so that we can later position them based on the data. Okay, and then I'll go into the legend a little bit later. It's not as important, so I don't want to lose track of what we're doing. Okay, so if we go back to start real quick to see what else is happening. I'm going to go to update all wedges right now because load slow just is a little more complex. So let's do the less complex, go over the less complex first. So update all wedges. We start by having this previous z, or prev z. Basically, this is the z degrees, rotation degrees of the previous wedge. So if we're working on one wedge at a time, this is the previous z degrees of the previous wedge. And in the first wedge, the previous z will just be 0 because that's the degree we're starting at, is 0. 0 degrees. Okay, so prev z, just to be clear, is degrees. It's a flow, but it's degrees. Okay. And then we're going to loop through the wedges backwards. I explained, or I said before, we needed to go backwards. We're going to loop through the wedges in reverse, and we're going to call this other function update specific wedge. And that function, you give it a wedge and a degree, the z degree of the previous wedge, and it returns the new previous degree, which is actually the current wedge's z degrees. And then you just use that again in the same function on the next for loop. So let's look at update specific wedge. This is where the rotation actually happens. So we grab a wedge from the PyWedges list using the index given. We can calculate where the wedge should start based on that. So what its z rotation should be essentially. And let's look at how we do that calculation. So the z-rot calculator. So it takes in, again, the previous z degrees, and it takes in a fill amount. And this fill amount is a value. It's not a percentage. And what we do is we take that fill amount, we divide it by the total, so now it's a percentage. We multiply that by 360, so it's a percentage in degrees. It is actually just degrees. You know, it's a percentage of the whole, which is 360. So now it's in degrees, and then we add prev z, which is also degrees. So we're ending up with degrees. We're adding prev z because if we were to look once again how this works, to know where to place, say, this, to place D, the D wedge, we need to add the degrees from E wedge and then whatever more degrees to make sure this lines up at the edge here. If you think of the center as right here, that's how we're determining the rotation. So that's why we have to keep adding prev z. If we are here with this C, we're going to need to add all of this, right? Which is prev z. Okay. Let's go back. So this is update specific wedge. That's how we calculate. After we've calculated, we're going to set our prev z to what we just calculated, because now in the future it will be the previous z rotation. And then here we're going to grab the Euler angles. So this is the same thing as the x, y, and z rotation angles of each wedge. So we're going to grab the Euler angles of this wedge, and we're just going to change the z. So we're just going to add to the z of that vector 3, and then we're going to set it the Euler angles of the wedge to the new vector 3 that has that z change. Okay, and then now we're going to change the fill amount. You need to rotate it and you need to change the fill amount. So we're accessing the fill amount, and we're just using the value. This wedge.fill is the value, and we divide it by the total, and that gives us that percentage, which is what we want for the fill amount. And then this text part, we're gonna set what the value reads. That's what this is. This is that text. So we're grabbing this text, and we're also going to set it as the first sibling because we're going in reverse, just because this puts them in order. And then the text value, these text values, they get flipped after 90 degrees. So we just flip them again to make sure they're facing the right direction. Because these text values are attached to each of these wedges, so they get rotated with the wedge. And when they get rotated, maybe to say here, for example, this 80 would be upside down, because if you think about how it's rotating. And so would this 10.4, and so would this 30. And so we just flip anything that's past 90, we flip the text. Okay. And then finally, this is where we're putting all the information into the text. We're setting the wedge to true. So after we've done all this, we know that the wedge is finally ready to be shown. So we activate the object. And then we return the previous z so it can be used for the next update wedge call. So that might have been a lot to take in. It's really not too bad. Look over it a little bit. Let me know if you have questions. Let's just go over slow load real quick. So this is an I enumerator, and what's great about an I enumerator is it gives you the ability to use this wait for seconds call. I enumerators run in tandem to the main thread. So this is threading, and so that means that it can wait on this thread without interrupting the main thread, so that you can do something on the main thread and you can still have something stop a different thread. So we want this to stop this other thread for a certain amount of seconds. In this case, I think it's 1 second, so that we can update it slowly rather than updating it every frame. So this slow load pie chart I enumerator, or coroutine, it's called a coroutine. We're going to use this variable wedge counter to determine if which wedge we're on. So we're starting at wedge 0, and then wedge 1, wedge 2. Every time, actually in this case we're going back to front again. So we're actually starting at the number of wedges minus 1, because it's 0-based indexing. So so wedge counter right now, or in the beginning, is equal to the number of wedges minus 1. And then every time we update a wedge, we're going to subtract 1 from the wedge counter, and then when it's less than 0, we know there's no more wedges left, so we just break out of this coroutine. And this is a recursive coroutine. It's calling itself at the end of the coroutine. And this should be fine though, because wedge counter we know is going to be 0, so it's okay. Also, the nice things about coroutines is since even though it's recursive, it's not actually a while loop. So if this were to go on forever, it would still only use the same processing as if you were to run it once. It's just it would be constant. That space would always be taken up, but it wouldn't take up any more, if that makes sense. So it's not really that dangerous of a recursive function, because it's not in a while loop where it's going to keep creating new threads. Because once this finishes it will get rid of the thread. So, okay. So start coroutine, that's how you start a coroutine. If you just call the function by itself, it won't do anything because it's an IEnumerator, and IEnumerators need to be started using start coroutine. And so every time we're calling this, we're just giving it the same wait time that we started with, and we're giving it the new updated previous z value. And we're once again just calling this update specific wedge based on the wedge counter. And so that's how we do the slow load. Okay, that's basically it for the pie. We look at the legend real quick. There's not too much to do with the legend, but once again, we're just instantiating a legend object. We're setting the parent of the legend to this legend object I've created. Something you should know about this is I've added a vertical layout group. What this does, maybe I can give you an example. So a vertical layout group, if you set the control child size to width and height, it'll always resize whatever its children are, depending on the number of children, to fill up the entire width and length of the layout group. So if I add another legend item, now it's split it directly in half. You can add padding and spacing. Spacing will add spacing in between two objects. Padding will add spacing between, like, let's say, for all of them, let's say from the left or from the right or from the top or the bottom. So for an example real quick. See, it added 199 spacing on the left. Okay, but I don't want that, and I don't want these in there. Anyway, so my pie chart has access to this legend, and it has access to this prefab, this legend item prefab. And so what it does is it creates that prefab. It sets legend as a child of the parent. If you notice here, I didn't actually zero out the position, and that's because when you're using a layout group, or vertical or horizontal layout group, it auto positions it, and so you don't need to zero it out because it's just going to force it into place. And then we set the color and we set the text. And I believe that's it for the legend. The legend, there's not really too much um, else that the legend needs to do. You can add more functionality, but that's basically it. So that is essentially how you make this pie chart. It's not too bad. It's all in one script, which is nice. And the really important and helpful piece is to know about this fill amount. So I think that's it for now. I hope you enjoyed this tutorial. Let me know if you have any questions. Thanks for watching.